Hi all, and welcome to 12.2. Just talking about stoichiometry real quick. So with stoichiometry, remember that is basically just a fancy word to say dimensional analysis. And what we're able to do with that is say, if I start with this much reactant, how much product am I going to get out? And you can imagine why that might be useful, right? Think about even just like something like cooking. You know the famous taco example that I beat to death in class whenever we were going over stoichiometry. So all we're doing here is dimensional analysis. Now, we all got pretty good at doing our math this way, and I will tell you for AP, it must be done this way. So make sure that we do it this way. Okay, so we're just going to do an example, and then that'll be it here. So in the lab, the amount of substance is usually determined by measuring mass in grams, and we're going to use this example. So here is our chemical equation. Nitrogen gas plus hydrogen gas yields ammonia. And notice that it is already balanced for us. You have to have a balanced equation when doing stoichiometry problems. So this says calculate the number of grams of ammonia produced by the reaction of 5.4 grams of hydrogen with an excess of nitrogen. So we always start with what we know. So we're just going to begin with the 5.40 grams of hydrogen. So grams of H2. Remember that hydrogen is a diatomic element. So we have 5.40 grams of H2, and we need to convert that and figure out how many grams of ammonia are we going to get back whenever we react 5.4 grams of hydrogen. So if you remember, we need to go from grams to moles, use the mole ratio, and then moles to grams. So the only way we can go from grams to moles is to use the molar mass. And the molar mass of hydrogen is 2.016 grams of H2 for every 1 mole of H2. Now that we're at moles of hydrogen, because gram on top cancels with gram on the bottom, we use our mole ratio. So for every 3 moles of hydrogen I have 2 moles of NH3. Because remember, that's where we're trying to get to. So we're leaving hydrogen behind, and now we're working towards ammonia. Now I'm going to go from moles to grams of ammonia. So I need to use the molar mass of ammonia. So that is 14.01 plus 3 times 1.008, because I have 3 hydrogens. So that's 17.034 grams of ammonia for every mole of ammonia. Mole cancels with mole. We're left with grams of ammonia. And now all we do is multiply across the top, multiply across the bottom, and divide the two. So 5.4 times 2 times 17.034 divided by 2 times 3. Divided by 2.016 times 3. And that gives me an answer of 30.4178, yada, yada, yada. But we started with 3 sig figs, so we're going to end with 3 sig figs. 30.4 grams of ammonia. So again, what this means is when we react 5.4 grams of hydrogen with an excess of nitrogen, we're going to get 30.4 grams of ammonia in the end. In this same chapter, we've also talked about limiting and excess reagents. Remember, the limiting reagent is the one that runs out first, and the excess is the one that is in excess or left over. So again, think about the taco example. If we have 10 pounds of ground beef, seasoned, cooked, ready to go, but only 2 taco shells, we're only going to be able to make 2 tacos because the taco shells are our limiting reagent and the beef would be our excess reagent.